All right, in this video, we're taking a look at section 4.2, which is the mean value theorem. And this is going to involve a story about Harold and Maude. They are taking a road trip, and I must tell you, this happened before the coronavirus issue. They are being responsible and hunkering down and practicing social distancing now. But before the crisis, they went on a road trip. Okay. Now, we have to decide who's driving. I always let the class decide, but it's hard to hear you through the video camera. So I'm going to flip a coin. Since Harold starts with H, if it's heads, Harold is driving, and if it's tails, Maude is driving. And I'm probably, oh, I didn't drop it. Wow. Okay, Maude is driving. It was a tails. Okay, so they're going on a road trip. Here is a road. Okay, and at some point, they pass a toll booth. Now, we have toll roads out here, but basically that means you get a little transponder in your car and you drive through and it beeps, okay, and then your credit card gets charged. Okay, but this is a very old-fashioned toll booth. When you drive through this toll booth, you stop. You roll down your window. It's old-fashioned. You're still rolling down windows instead of just hitting the button, okay? You interact with a human being who is called the toll booth agent, and you get a little piece of paper. And that little piece of paper indicates that it is 3 p.m. and that Harold and Maude are here at this particular location. So it's indicating what time they got on the toll road. Okay. And then they drive along for a while. So here's their beautiful car, and it's driving like so, and there's the window. Okay, a lovely picture indeed. Okay, but they hit another toll booth where they're going to leave the toll road, and they hit that at 4 p.m. So it's 1 hour later. Okay, so now they're there. They have gone from here to there, which is a distance of 100 miles. Okay. So Maude hands the ticket to the toll booth collector, and the toll booth collector says, "Thank you very much. That will be $243. And Maude says, "Well, Madam Toll Booth Collector, that's rather expensive. I mean, we were only on this road for 100 miles. That's crazy. How can it be that much?" And the Toll Booth Collector says, "Oh, the toll was just $5. You have to pay a speeding ticket because you just traveled 100 miles in 1 hour." Now, Maude says, "Oh, dear." But she's going to try to talk herself out of this. So she says, "Madam Toll Booth Collector, I understand that it seems like I might have been speeding, but I assure you, I am a calculus student, and I know the difference between average speed and instantaneous speed. And even if we grant that I was going in the positive direction and my average velocity was 100 miles per hour, that does not prove that my instantaneous velocity at any moment in time was above the speed limit. Therefore, I will not pay." Well, does Maude pay? Of course, the answer is yes, she does. But the reason is very interesting because the toll booth collector says, "Oh, you poor dear sweet first semester calculus student, you should have finished the class. You see, I did, and I learned something called the mean value theorem. And do you know what it means? It means that you have to pay that fine." Okay. So let's actually state the mean value theorem, and then we'll see how it relates to this lovely but tragic story of Harold and Maude. So many of their stories are tragic. Okay, the mean value theorem says if f of x is continuous on a closed interval from a to b and differentiable on the corresponding open interval from a to b. So it has to be continuous, including at the endpoints. It's okay if it's not differentiable at the endpoints, but it has to be differentiable everywhere in between. Then there exists, oh dear, I'm going to have to erase some things. I'll keep the road there so we can refer back to it, but goodbye toll booths and car. Okay, there exists an x value c in the interval from A 2b, so somewhere in between those endpoints, such that f prime at c, which we know exists because c is in the middle, somewhere in the middle, and the function is differentiable on that open interval, f prime of c is equal to f of b minus f of a all over b minus a. Okay. So that's our statement of the mean value theorem. Okay. So how does it relate to this story about Harold and Maude? Well, in this case, we basically had two functions that were relevant. We had their position as a function of time. So we would have had position as a function of time. Now, I know that a position function is continuous, because if I want to go from here to there, I don't just suddenly become there. I have to slowly transition from here to there. So position functions are continuous. And I also know that they're differentiable, because I know that the derivative of position is the velocity function. Okay. So, Maude's position was continuous everywhere from 3 o'clock to 4 o'clock. It was differentiable everywhere. It was even differentiable at the endpoints, but we don't care. We don't need that. So there was some time in between 3 o'clock and 4 o'clock where the derivative of her position function, which is her velocity, was equal to this. What is that? Ooh, I can think of that geometrically, or I can think of that in terms of applications. In applications, I'm going to think of that as being a rate of change. I know that a derivative is an instantaneous rate of change. This is the slope of a secant line, which would be the average rate of change. So Maude's instantaneous velocity had to match her average velocity at some point. And her average velocity was 100 miles an hour, so she was definitely speeding. If I want to think of this geometrically, this is the slope of the tangent line. This right here is the slope of a secant line. Okay. So that's what the mean value theorem says. We'll come back and talk a little bit more about that in the next video. See you then.